chapter 2, vector, lesson 1. In this lesson, we will know about vector and scalar quantities. Now, the objective of our lecture is to learn the definition of quantity, definition of vector quantity, definition of scalar quantity with some examples, and we will know 5 properties of vector quantities. Now let us proceed towards the lecture. Okay, coming to the definition of quantity, what is a quantity? Whatever can be measured in this physical world is called a quantity. Now let us see what can be measured. Time can be measured, length can be measured, mass can be measured, velocity can be measured, distance can be measured. These all are called quantities because they can be measured in this physical world. What is physical world? The world we are living in is called the physical world. Now coming to the types of a quantity, quantity is of 2 types. Number 1, vector quantity. Number 2, scalar quantity. Now let us see what is a vector quantity. The quantities which require both magnitude and direction for their full description are called vector quantities. Now let us see what does magnitude mean. Magnitude is the primary prerequisite of a quantity. So whichever things have magnitude is a quantity, whichever things do not have a magnitude are not a quantity. And coming to the term direction, suppose you are traveling towards north 10 meter, then you have a displacement of 10 meter. But if you travel towards nowhere 10 meters, we can say this is called distance. We can say distance is a scalar quantity and displacement is a vector quantity because displacement has direction whereas distance do not have direction, and the quantities which do not have direction are called scalar quantities. Coming to our second example, which is weight. What is the direction of weight? We know W equals to mg. M is mass and g is acceleration due to gravity, and the direction of acceleration due to gravity is towards the center of the earth. So the weight of a person is directed towards the center of the earth. So weight is a vector quantity because it has direction. Coming to our third example, which is velocity. Velocity is the vector term of speed. In case of speed, we do not have the direction. Suppose you are traveling at 10 meter in 3 seconds without any direction. We call this is speed. But if we say you are traveling 10 meter in 3 seconds towards north, then we can say this speed is velocity because whenever speed has direction, we call it velocity. So we can say speed plus direction equals to velocity. Speed is scalar quantity and velocity is vector quantity. Now coming to our fourth example, which is acceleration. Acceleration works the same way as velocity. Just what is acceleration? Acceleration is the rate of change of velocity is called acceleration. That is v divided by t. Our fifth example is force. What is force? Force is the external cause for which the state of an object is changed towards a definite direction. That means force is related to a definite direction. Suppose the box is here and due to an external cause the box traveled here. So we can say force occurred in a definite direction. If we say the direction is north, then the action of this force is towards north. Coming to our sixth example, we can say electric intensity. Electric intensity acts towards a definite direction, intensity of an electric field. Suppose the intensity works, this is an electric field and it is exerting intensity towards all the directions. So we can say it has a direction towards all the sides. So since the electric intensity has direction, and for this reason this is called a vector quantity. Now our vector quantity topic is finished. Now we will proceed towards the next topic, which is scalar quantity. So what is a scalar quantity? The quantities which can be described by magnitude only, no direction is needed, they are called scalar quantity. For example, length of a scale is suppose we can say 30 centimeter. Length of a scale is 30 centimeter. To express this quantity we do not need direction, so this is called scalar quantity. And if we add direction to length, then we get displacement, which is a vector quantity, vector. And our second example is mass. Suppose I can say my mass is 58 kg and it does not need any direction to be expressed. And our third example is speed. In case of speed, direction is not needed. In the velocity, in the vector part, I described about speed. If we add direction to speed, we get vector, which is velocity. Number 4, work. We know when displacement occurs with the application of a force, we call that work. The formula of work is F dot product S. What is dot product? Dot product is the product of two vectors whose resultant is a scalar quantity. Again I am saying, when we get a scalar quantity by the product of two vector quantities, then the operation that is done is called dot product. So work is the dot product of two vector quantities, which is force is a vector quantity, as that is displacement is a vector quantity, and the dot product of these two vector quantities is work, and that is dot product. By dot product we get what? Scalar quantity. Now coming to the last topic of this lecture, properties of vector. We will learn about 5 properties. Number 1, vector quantities require both magnitude and direction for their full description. So suppose this vector quantity lacked magnitude. What is the prerequisite of a quantity? We can call something a quantity if it has magnitude, but if it doesn't have any magnitude, we can call it a quantity, let alone vector quantity. So magnitude is a must. And in case of direction, if it didn't have any direction, we couldn't have called it a vector quantity, then it would have been scalar quantity. A quantity which lacks direction is called a scalar quantity, but since it has direction, we can call it a vector quantity. And direction, and both magnitude and direction, is a must for a vector quantity. Number 2, a vector quantity changes if its magnitude or direction or both changes. In case of magnitude, suppose you are traveling towards north and your displacement is 10 meter, and in second case your displacement is 8 meter. In this case, due to the change of the magnitude, the vector quantity also changes. Now in case of direction, your displacement towards north is 10 meters and your displacement towards south is 10 meters. These both quantities are also different due to the change of direction. Now if the both changes direction and magnitude, then your vector quantity will also be changed. Now coming to the third property, we get addition, subtraction, multiplication of vector quantities cannot be done by simple algebraic laws. These are done by the vector algebra. Okay, we all now know about the algebraic laws. Now in case of vector addition and vector subtraction, we follow two rules. Rule number 1 is law of triangle, and rule number 2 is law of polygon, which is a corollary of triangle law. Okay, in case of multiplication operation, we follow two rules. Rule number 1, dot product or scalar product, and rule number 2 is cross product or vector product. What is a dot product? Dot product is the operation in which by the product of two vector quantities we get the resultant scalar quantity, that is called dot product. And in case of cross product, we get a vector quantity with the multiplication of two vector quantities. In case of dot product, when a vector quantity is multiplied with another vector quantity, we get a scalar quantity. And in case of cross product, when a vector quantity is multiplied with another vector quantity, we get a vector quantity. So this is all about the third property of vectors. Now coming to the property number 4, we get product of two vector quantities may be 0 though none of them is 0. So we have to express this property with an example. Suppose A is a vector which is expressed as 2i plus 3j plus 4k. B is a vector which is expressed as minus 2i minus 4j minus 4k. Now if from this we can see that magnitude of A is not 0, magnitude of B is not 0, but their product will be 0. What product? Dot product, but their dot product will be 0. Let us see. A dot product B is equals to 2i plus 3j plus 4k minus 2i minus 4j minus 4k. 2 into minus 2 equals to minus 4. 3 into minus 4 equals to minus 12. 4 into minus 4 equals to minus 16. I did a mistake here. In case of B vector, the last one will be plus 4k. Plus 4k. So if we multiply 4k with plus 4k, then we get plus 16. So if we calculate this, we get 0. The magnitude of dot product of A and B is 0. So our fourth property was product of two vector quantities may be 0 though none of them is 0 is explained. Now coming to the last property, which is property number 5, we get depending on the nature of their multiplication, product of two vectors may be scalar quantity or vector quantity. Okay, this property was mentioned in here, which is in case of dot product we get scalar quantity with the multiplication of two vector quantities, and in case of cross product we get a vector quantity with the product of two vector quantities. So the fifth property is also explained, and thus this is the end of this lecture.